In the 17th century, Italian scientist Galileo Galilei tried to measure how fast light travels. He was one of the first people to attempt this, and he had to think of a brand new and clever method to do it. Galileo's experiment used two people who stood on different hilltops that were several miles apart. These hills were far apart but still close enough for the people to see each other. Galileo and his assistant each had lanterns with covers to block the light when needed. This was a small choice because the lantern's light could be seen at night from far away. The plan was simple. At a set time, Galileo would uncover his lanterns to send a flash of light. His assistant standing on the other hilltop would watch for the flash. As soon as the assistant saw Galileo's light, he would uncover their own lanterns and send a flash of light back to Galileo. Galileo wanted to find out fast light travels by measuring the time it took for the light to go back and forth between the two hilltops. To do this, he needed to be very precise with timings and know the distance between the hilltops very well. Galileo faced a big challenge during his experiment. The tools he had in the 17th century were basic and not made for such exact measurements. Timing how long it took between the two flashes of light was hard because light travels so fast. The delay would have been too small to notice with the instrument he had at a time. The distance between the hilltops made it difficult for Galileo and his assistant to stay on the same schedule and communicate clearly. Even small difference in timings could lead to major mistakes in their calculations. Despite these challenges, Galileo's experiment was a first try that opened the door for the future research on the speed of light. Although his results were not certain, his bravery and creative ideas inspired other scientists who eventually managed to measure the speed of light accurately. After Galileo, Romer was a scientist who was curious about mysteries of space, particularly the speed of light. He looked at the four man-moons of Jupiter, Io, Europa, Ganymede and Callisto to find clues about how fast light travels. Romer carefully watched these moons as they orbited around Jupiter. He observed that when Earth was closer to Jupiter, the moon seemed to move faster around the planet. When the Earth was further away from Jupiter, the moons appeared to move more slowly. These observations helped Romer understand that the speed of the light is not instant. Instead, it takes time for the light to travel from one place to another. By studying these challenges in moon's movements, Romer estimated that light travels at about 220,000 kilometers per second. This was an important discovery because it was one of the first time anyone had measured the speed of light. After Romer, Einstein came along in the early 20th century and changed the way we see the world forever. Einstein talked about something called space-time, which is like a big fabric that combines space and time together. In his theory, Einstein said that nothing can go faster than light because light has a constant speed that can't be changed. He also came up with this famous equation E is equal to mc square. This equation shows how even small amounts of matter can contain a huge amount of energy, especially when you consider the speed of light. Scientists have done lots of experiments to test Einstein's ideas and they have found that he was right. One famous experiment in 1919 called the Eddington expedition watched how light from stars bent around the sun during a solar eclipse, which helped prove Einstein's theory. After Einstein, two scientists named Michelson and Morley did an experiment called the Michelson-Morley experiment. They wanted to see if the Earth moved through something called the luminiferous ether, which was thought to be a special substance that light traveled through. But when they did the experiment, they were surprised to find that the speed of light was the same no matter which way they measured it, even if the Earth is moving in a different direction. This was unexpected and showed that the luminiferous ether probably didn't exist. Einstein came up with a new idea called special relativity to explain this. He said that the speed of light is always the same, no matter how fast you are moving. This changed the way we think about the space and time. Today, scientists use advanced methods like laser technology and satellites to measure the speed of light with incredible accuracy.